Good afternoon, all of you. In today's session of class 10 physics, we are going to discuss one topic, the important ray diagrams related to refraction. So we'll discuss a couple of very important diagrams, and then I'll give you one ray diagram as a homework. Now the first important ray diagram, it is called advanced sunrise and delayed sunset. So basically what happens is that you are aware that throughout refraction we are always considering that air and vacuum are the same. So throughout our study of refraction we are always saying that whether it is air or whether it is vacuum, both have a refractive index of 1. That is what we have been saying. But the truth is that although it is correct to say that vacuum has a refractive index of 1, air has a slightly higher refractive index. So the refractive index of air is something like 1.000029. So the refractive index of vacuum is 1, but the refractive index of air is about 1.000029. So because of the difference in refractive index of air and vacuum, there are certain phenomena that happens during atmospheric refraction. So suppose this is the sun, and the rays of light from the sun are coming and they are passing through the atmosphere. So this dotted line represents the atmosphere. So the rays of light are coming from the atmosphere and they are constantly bending and finally going to the eyes of the observer. So there is one observer over here, and the rays of light from the sun, they are coming and they are refracting and continuously bending and going to the eyes of the observer. Now if you produce the last ray backwards, then it will appear to come from a place above the horizon. Remember that the sun is about to rise. So this is the horizon. Horizon is the straight line passing through your eyes, which is tangent to the earth. So this is the horizon. The sun has not yet risen. It is early morning and the sun has not yet risen. So the sun is about to rise. But the rays coming from the sun, because they are constantly bending inwards, and finally when they reach the eye of the observer, the last ray, if you produce it back, it appears to be from above the horizon. So this gives an impression of advanced sunset, advanced sunrise. That means the sun has not risen, but the observer will get a perception that the sun has already risen. So this phenomenon is known as advanced sunrise. Now the thing is that the angular separation between these two positions, like this position and this position, the angular separation is approximately half a degree, right? The angular separation is approximately half a degree, and in terms of time gap, the gap is around 2 minutes. So this phenomenon is called advanced sunrise and delayed sunset, and this is observed both at sunrise and Okay, so sorry for that interruption, all of you. There was some network issue due to which this video got interrupted a little bit. Now the thing is that basically, as I was telling you, that due to advanced sunrise and delayed sunset, so the gap is half a degree. So half a degree gap means that the difference between the sunrise and the apparent sunrise is half a degree, and in terms of time it is 2 minutes. Now the same thing happens during sunset. During sunset, the sun, when it is still above the horizon, it appears to be below the horizon. So the same thing happens. There also it is half a degree, there also it is 2 minutes. So this is one of the concepts. Then okay, so basically the second concept is mirage. Now what happens is that if it is a very hot day, a very hot day, and typically in the desert areas, so suppose there is a tree and it is a very hot day and it is a desert area, so there is a tree, so the rays of light will come from the tree. Okay, the rays of light will come from the tree, and they will keep refracting because the air just above the ground is very hot and refractive index is less. So as you go from the tree downwards, the refractive index decreases. So as you go from the tree downwards, the refractive index decreases. So the air will keep on refracting, and finally when it reaches a certain level just above the ground, the air, the density of the lower layer will be so low that the ray of light will not refract, it will actually reflect and turn back. Now this happens when the angle of incidence reaches a critical value. You understand that when light is going from a denser to the rarer medium, the angle of refraction will keep increasing till it reaches 90. But angle of refraction cannot be more than 90. If it is, that means the ray will internally reflect and come back to the same medium. So the ray of light will internally reflect and go back to the same medium, which is air, and finally it will go to the eye of the observer. If you retrace it, it appears to be coming from here. So this observer will think that this is the image of the tree. So he will think that there must be some water body over here, and that is why he is able to see the image of the tree. So this phenomenon is known as a mirage. So a mirage is typically found in very hot summer days in desert places where the air which is very close to the ground has a lower refractive index, and at that particular level of air the ray will undergo total internal reflection and give the impression that the image is formed by some water body. So this person will get an optical illusion of some water body, and that is known as a mirage. Okay, now the ray diagram, homework ray diagram. The homework is that a person is standing over here. This is your homework. A person is standing over here. There is a container full of liquid, suppose water. Okay, so there is a container which is full of liquid, suppose water, and at the bottom of the container one object is kept. So a person is observing right above the object, like the eye of this person is straight above the object. So you have to draw the ray diagram and show that how the apparent position of this object will be different from the actual position. So you will have to draw a ray diagram and show it. So this will be your homework and you have to submit it by 9 p.m. tomorrow, that is Monday. I'll end the session. Bye all of you.